System sizing. So we're going to start getting all this information that you guys have learned over the last couple modules and put it together and size a system together. Now, it's important to understand, as solar consultants, this won't be something that you'll ever actually do yourselves, but it's important to understand how it's done so you have confidence when you're giving this information to your homeowners. Now, to figure out how to size your solar system, you take the kilowatt hour energy requirement, then divide it by the peak sun hours to get the kilowatt output. Then you divide the kilowatt output by the panel's efficiency to get the estimated number of panels you'll need for your system. Let's break this down, and we're going to do it in segments so you don't have to worry about taking a ton of notes on what I just said and try to figure it all out. I have the equations written out for you guys. When we get the system, first we need the annual kilowatt hour requirement. So if we take a look at this graph off to the left, this is a 12-month of a customer's usage. We need to take a look at a couple factors, including when they're using the most power and what their peak demand is going to be, so we can properly size the system. So first, we're going to get the azimuth, the tilt, the shade, the location. This will get the peak sunlight hours or the yield. Annual kilowatt hours divided by the peak sunlight hours equal the system size. So let's use 14,500 kilowatt hours, for example. Let's say the yield is 1.7. That's going to give us an 8,529 watt system. Bonus points if we want to put that into kilowatts, 8.529. Now, let's figure out how many panels we need for that. So it's the system size divided by the panel wattage. Let's use 350 watts for this example. So 8,529 divided by 350 watts is going to be 24.116. Can I cut a panel into a tenth? If you're shaking your head no, good job. No, you cannot cut it into a tenth. So what are we going to do? We're going to round up the number of panels to give us our true system size. So we get the new number of panels and multiply that by 350, which is the wattage of our panel. That's going to give us an 8.750 kilowatt system, or 8,750 watt system. So the last thing we're going to figure out is the offset. This is going to be the amount of utility going to be offsetting by the solar production. So it's the system size divided by the yield or peak sun hours will give us the produced kilowatt hours. Then you divide that by the required kilowatt hours. So 8,750 times our yield, which was 1.7, is going to give us 14,875 kilowatt hours produced. If we divide that by the required kilowatt hours of 14,500, we get 102% offset. Now, let's say that we're comparing systems with another company. We need to figure out what they determine to be the yield or the peak sun hours. So when comparing it, all you have to do is get the produced kilowatt hours and divide that by the system size. Why is this important? Well, we've seen this happen multiple times where some companies don't take shading into consideration, or they're not properly using the azimuth, and they might say that they're going to produce 14,875 kilowatt hours with a 7 kilowatt system. That's going to give them a huge yield, when the proper yield on this one is about 1.7. So you can have confidence going into these consultations and these comparisons, knowing that we take all these factors in consideration before we figure out the yield. So now let's figure out some price per watt. Company ones, it seems to be about $2,000 less expensive on this one. So compare the system size and the price. Let's say they're $25,855 and they're at a 7,500 watt system or 7.5 kilowatt system. This means that they're going to be at $3.45 per watt. Okay, so if they're at $3.45, let's build this out a little bit more, because now we're going to show the size difference and the price per watt. So we're going to find out our price per watt. We're going to take our 27,125 and divide that by our system size of 8,750 watts. That's going to give us $3.10 per kilowatt hour. Well, if the competitor was to price our system at their price, they'd be at $30,164. So how do we find out this difference? So subtract the competitor system cost and our system cost. That's going to give us the true difference. So 30,164 to minus 27,125, if they give the same system size, they're going to be $3,039 more expensive. So they may have lowered the system size in order to be able to increase the price to increase commissions, which means that they're going to be undersizing the system. So let's take a look at something on this, because it's important to understand with that competitor how we broke it down. And I would show this on a piece of paper just like I'm showing you guys here. I would draw it out for the customer. So this company over here is at $25,855 for a 7.5 kilowatt system. Again, that's $25,855 divided by 7,500 watts is $3.45. Meanwhile, our $27,125 system is an 8.75 kilowatt system. So we divide the $27,125 divided by 8,750. That gives us $3.10. So let's just flip it for them and show them exactly what happens when you put these two systems together. If they were to price our system size, they'd be at $30,188. But if we were to price their system, we'd be at $23,250. Most customers don't know what a price per watt is. So when you break it down for them, teach them the difference and what it would look like when comparing against the two companies.